Hello and welcome to another video for O-level math. Today what we're doing is we're continuing with sequences. The next thing that I have for you here is basically the nth term of a quadratic sequence. Okay, now first let's try to understand what a quadratic sequence is. Let's see the sequence that we have right here. Okay, what happens in this sequence is to get to every next term, what you're doing is first you're adding 3. Okay, so that's plus 3. Then there's a plus 5, there's a plus 7, so plus 9. So it's different from a linear sequence or an arithmetic sequence in the way that you don't have a common difference between each term. But if you see these differences, but these differences are consistently spaced. So each of these distances is just 2 apart. Okay, so every next term is basically calculated by adding the 2 to the difference of the previous term. Okay, I hope that settles the question as to what a quadratic sequence is. So you see there are 2 levels of differences. There's a first difference and there's a second difference. Now I must warn you that there are a lot of ways of teaching quadratic sequences, and a lot of people will teach in different ways, and that's absolutely fine. Whichever way you understand better is the way that you should go with. Not you shouldn't be influenced by the fact that I am teaching this or someone else is teaching it, and that's the only way of doing a question. Okay, what I'm teaching you here is that there is a formula for the nth term of a sequence. Okay, what is the formula for the nth term of a sequence? It's first term plus n minus 1 times the first difference, and then plus n minus 1 into n minus 2 into second difference divided by 2. Now it's a long formula and you need to remember it if you want to do well at these questions. Okay, it also does say at the end that this method is rather long-winded. It may be better to appreciate that any quadratic sequence will be of the form ax squared plus bx plus c, where a is equals to half of the second difference. I'm also going to explain this idea to you with a question. Okay, when I come up on an nth term question, I am going to show this idea to you. I'm going to solve it in 2 different ways. Okay, so the first 4 terms in a sequence is shown in the diagram. The patterns are made from the square tiles that are either white or colored. Okay, so in the first thing that I'm saying, find separate expressions in terms of n for the total number of white tiles and the total number of colored tiles in the pattern. So let's first list down what the white tiles are and the colored tiles are. So colored tiles in pattern number 1, let's create something of a table. So colored tiles. Okay, let's call that pattern 1. Okay, how many colored tiles? I see 2. Pattern number 2, I have 4. Pattern number 3, I have 6. Pattern number 4, I have 8. So color tiles look relatively simple. They are in arithmetic sequence. The color tiles is just it's just a plus d times n minus 1. So a plus d, the common difference between each of the terms is 2. Well, a is also 2. Okay, so 2 plus 2n minus 2. So 2n just. Okay, let's talk about the white tiles. There was 0 white tiles in the first one. 0. That's 3 in the second one. And 4, 5, 6, 7, 8. 8 in the third one. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this doesn't look like a linear sequence to me. Does it look like a quadratic? Yes, it looks like a quadratic. So there's a plus 3, there's a plus 5, and there's a plus 7. And these terms have a common difference between them. So there are 2 levels of differences. That means that the white tiles are a quadratic sequence. Now, what is the formula for a quadratic sequence? Let's look at this. This is first term. So what is my first term? That's 0. What is the first term? And then I put a plus n minus 1 times the first difference. What is the first difference? This is the first difference that I want you to acknowledge, We'll always use the first difference. So n minus 1 times 3 plus n minus 1, n minus 2 times what? I want the second difference, second level difference. I want to call that the second level difference divided by 2. Okay, so second level difference divided by 2. So what is the second level difference? That's 2 divided by 2. Okay, so that gives me 1. This gives me 3n minus 3 plus n minus 1 times n minus 2. Okay, if you expand the bracket, that's going to give you the expression for everything that you require. N square minus 2n minus n plus 2. N square minus 1 basically. Okay, now is there an alternate way of doing it? Yes, there is an alternate way of doing it. What I want you to realize is that every quadratic sequence can be written in the form ax square plus an square plus bn plus c. Okay, a is always half of the second difference. That is what this expression was telling you. What is a then? A is basically 2 divided by 2, half of 2 basically. So that gives me 1. Okay, so my expression becomes 1n square plus bn plus c. Now, how do I find the rest of the terms? Okay, remember that this is tn. Do I know term number 2? Yes, I know term number 2. Term number 2 was in this case 3. So can I say 3, 1 times 2 square plus b times 2 plus c? That gives me 2b plus c, and I subtract, this gives me 1. So it creates what I think is a simultaneous situation. Can I see the next term and say that 6 equals to 1 times 3, sorry, not 6, 8 equals to 1 times 3 squared plus b times 3 plus c. So that gives me 9 plus 3b plus c equals to 8. 3b plus c is basically minus 1. Okay, then I would have to solve this simultaneously. So I think this is a rather longer process, and learning the formula is, I think, per se useful. Okay, I can change these and come up with the final answer. Have I done something incorrect in the previous one? I think I have made a mistake somewhere. Okay, yeah, I think there's a calculation mistake here. There should be minus 1. So I get minus b equals to 0. Okay, so that is what I think I was expecting, because there's no second term here. And then once you have 0, you can just say that I can plug it in and find c. I personally think that this method of I am creating simultaneous equations and then solving them is much more complicated than just simply remembering this formula. I am telling you this, that if you remember the formula, you will probably be able to solve all the questions. Okay, I need a formula for the total number of tiles as well. So that's the colored tiles plus the white tiles. So n square plus 2n minus 1. Okay, then it says use your part answer to part A to write an expression for the total number of tiles in pattern N. That's what I've done, although that was asked before as well. Hence, find the total number of tiles in pattern 32. So pattern 32 is just simply total number of tiles. Total number of pattern 32 would be 32 square, which is 1024 minus 1. Let me put that on my calculator, and I think that should be my final answer. So 32 squared plus 2 times 32 minus 1. So the bottom line is that quadratic sequences are a little tricky. Make sure that you remember the formula and then you should find them easy to do. Okay, let's do a few more questions. This is series of diagrams using three types of triangles shown. The triangles are gray, white, or black. Let's see how many. What the question is saying, complete the diagram for diagram N. This is a paper one question, so I'm not allowed to use a calculator. Okay, so I'm just going to count. So that's the 4, 4, 4, 4, that's 16. Okay. Number of gray triangles. Oh, my bad. This is the number of white triangles. So that's 16. How many gray triangles do I have? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that makes more sense. Okay, what? No, I'm sorry. It's a little confusing to because the diagram is very different. I want to see gray triangles, white triangles, and black triangles. Okay, so let's first highlight the white ones. So that's 16. The gray ones at the edges, 1, 2, 3, 4, 5, 6, 7, 8. That's 8. And that's 12. Okay. Then it says complete the diagram for diagram 4. By considering the patterns, find the expressions in terms of n for x, y, and z. So what sort of a sequence do I have here? That's a linear sequence. That's just if I look at it closely, there's just multiples of 2. So I can just go on and write 2n. That would be the simplest way of doing it. If you're not sure, then you write 2 plus the common difference times n minus 1, a plus d times n minus 1, and you'd end up with the same answer, the 2n. So yeah, and then b, I can then see that b is basically just squares. Can you see 1 square, 2 square, 3 square? So I can just say y is basically n squared. What about the black ones? Let's look at the black ones closely. So they increase by 2, then they increase by 4, then they increase by 6. So this is a quadratic sequence. Why? Because it has a second level difference as well. Okay. So what was the formula? The formula was the first term plus the first difference, which is 2 times n minus 1 plus n minus 1, n minus 2. Second level difference. What is the second level difference? That's also 2, surprisingly. So that gives me the black tiles as z equals to 2n minus 2. And when you expand that, it's going to become n square minus 3n plus 2. So z is basically n square minus n. Okay. And I think it could be predicted in another way as well. And that's absolutely fine if you've done it directly. Moving on to another past paper question. I think I have a few more questions to go. So I have example 13 in front of you then. Example 13 says the first diagram in the sequence is shown. The diagrams are made up of dots and lines, each one in the centimeter long. Make a sketch on the next diagram in the sequence. This is going to be, I'm not going to draw the dots because it's going to be very complicated on the iPad. It's going to look something like this. So the blank spaces are basically dots. Okay. In fact, I will have to count the dots. So I think I'll have to draw them, but it should look something like this. Okay. Yeah. I'm just going to, in fact, I should have just gone with drawing them properly only. So, okay, so that's going to be 1, 2, 3, and 4. Yeah. Okay, so the dots with red then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Was I asked to count this? Yes. Number of dots is 25. Okay. area is 16. Okay, make a sketch. So I've done the sketch. The table below shows the diagrams. I've done the values of P and Q. So P is 25. How many number of 1 centimeter lines? I will have to count that. I can also try to look at the pattern, in fact, and rather than counting, I can just say that this is a +8, +8, +12. So this should be +16, I think. So it should be 40. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay, that's also correct. Whichever way you want to do it, you can get correct answers very easily out of this. This is a calculator based question as well. Okay, so write down each of the values x, y, z in terms of n. So what sort of a sequence do I have for x? It's just the area. So it's going like a square. So it's just going to be x squared. Then y is basically not starting off with a square. So I'm going to have to create something for this. Um, so let's see. That's let's write that down first. So I have 4, 9, 16, 25. Although it's a sequence of squares very clearly, but it's not starting with 1, so I can't really write a number for it right now. So it's going to be +5, +7, +9. Again, a second level difference, so +2. So y is basically going to be what? Y is going to be the first term plus first level difference times n minus 1 plus n minus 1, n minus 2 times second level difference divided by 2. Okay, so that's going to be 4 plus 5n minus 5. So n square minus 3n plus 2. So I'm going to get n square plus 2n plus 1. Yeah, okay, that sounds right. Okay, it says the total number of 1 centimeter lines in the first n diagrams is given by the formula, by the expression in the first n diagrams. Okay, so I'm adding up all the lines in the n diagrams is given by this. Use n equals to 1 in this expression to show that f plus g equals to 10 over 3. So 2 over 3, 1 cube, 1 square plus g times 1. So in the first n diagrams, the total number of what? 1 centimeter lines should be 4, right? So f plus g should be equals to 4 minus 2 over 3. F plus g would equal 10 over 3. What about 2? It says use n equals to 2 to find this expression. Okay, so when I have n equals to 2, what is the total number of lines? That's 16. So 16 equals to 2 over 3 times 2 cube plus f times 2 square plus g times 2. Okay, 16 over 3. 4f plus 2g equals to 48 minus 16 is 32 over 3. Then from there on, it's just simultaneous equations. It says part 3, find the values of f and g. So I can have a lot of topics merged into this idea, and it's very important to understand this topic. So I can do f plus g equals to 10 over 3 and 4f plus 2g equals to 32 over 3. I can do, I think, just eliminate g by elimination. That's 2f plus 2g equals to 20 over 3. And that's 4f plus 2g equals to 32 over 3. So minus, 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 this cancels out, minus 2f. What's 20 minus 32? That's minus 12 over 3. So 4 minus 2f equals to minus 4f equals to 2. When f equals to 2, that's 2 plus g equals to 10 over 3. So g equals to 10 over 3 minus 2. G is then equals to 4 over 3. I understand that it's become a very crammed up to here together, but those are the solutions. I can shrink them a little bit if you want, but I don't have enough space on this page, which is what I've got to edit in my workbook. Okay. Find the total number of 1 centimeter lines in the first n diagrams. So then Tn is basically 2 over 3 n cubed plus f was just 2, so 2n, and g was 4 over 3 n. So the first n diagram, so 2 over 3 10 cubed plus 2 times 10 plus 4 over 3 times 10. Okay, so this last question tells you that questions can be more complicated, they can lead into one another and connect with other topics as well. I'm just getting a final answer for this. This is 700. So how many 1 centimeter lines in the first 10 diagrams? That's 700 lines. That's the end of this topic. I will see you with another topic in the next video. Thank you for watching. Make sure to subscribe. And we'll be back with another topic, that's indices and sets. So keep watching.